Welcome to Math Superville. Today, I'm going to demonstrate how we can apply the Python programming language to accomplish what we discussed in the last video. In this presentation, I'm going to demonstrate how we can use programming to come up with the result 50. And we're going to apply looping structures within the Python programming language. So pay attention to the fact that we can be able to find the sum of I plus 10, where the lower index of summation is 1, upper index of summation is 4. And when we run through this summation, our result is 50. So we expect this result 50 whenever we do any of the programming that I'm going to demonstrate. So let's do it. Okay, so the first thing we're going to do is to look at applying what we call the for looping structure within the Python programming language. So this, I'm going to give several solutions to the task. So in the process, we want to demonstrate that our solution is 50. We are given a sigma with the summand being high plus 10. And the index of summation is 1 through 4. So it runs from 1 through 4. So whenever we apply the for looping structure, we are going to define our initial sum. And our initial sum is 0. We haven't added anything to sum of I. It's actually sum of I plus 10, but I'm creating a keyword called sum of I. And so I'm going to enter into the for loop now. So it's for I in the range, and the range is 1 through 5. So notice that we are stating that in the function range, the last number is not included. So the range of 1 through 5 should yield the numbers 1, 2, 3, and 4. It excludes the last number. So that should give us all of the i's that we need. So the next thing we're going to do is to find the total sum. And the sum should be sum of I is equal to sum underscore I, referring to each and every subsequent sum that you have already collected. Initially it is 0, and then we're going to add I plus 10, so that when I is 1, we will have 1 plus 10. And then since the initial value of sum of I is 0, so we'll end up with I plus 10 plus 0. And then it will continue to add up the next one. It will add up the next one, and then add up the next one, and then add up the last one. So a loop is sort of an iteration. You are going through the same task over and over again. So, and this should give us our output. So let's print. So we should have and you can see. So we have our result to be 50 as expected. So that is using the for loop structure within Python. The next method that I'm going to apply is what we call the while loop structure. So in the while loop structure, I'm going to create our I, which is 1. And then, of course, our initial sum is 0. And then we enter the while loop. So while I is less than or equal to 4, we enter the loop. So this is going to be an iteration that does something while a condition is false, is true, not false. So the condition has to be true. When the condition becomes false, then the process stops. So we need to have sum of is equal to sum underscore I, just like the previous one, plus I plus 10. So that gives us whatever the sum is as we iterate through this loop. And then each and every time we have to increment the I by 1 so that it will have a way to reach the terminating condition, which is when I becomes 5, then the I is less than or equal to 4 becomes false, and we will exit the for loop. So that should give us what we want. And I'll print just like the previous one. So instead of typing, we just copy this previous print statement. Sum of I, yes. So I should be able to get the same result, and it works. So you are able to apply what we call the while looping structure, and you can see how beautiful mathematics is. That's why we tend to say math is the language that is used in computer science. The next thing we're going to do is to use the sum function within Python. Before we use the sum function within Python, we're going to specify our list. So a sum requires a list of numbers. So I'm just to encode the entire list. Remember how I was going from 1 through 4. So here we are adding I to 10, just as we had said in this case. When I is 1, we end up with the first one. When I is 2, we end up with the second one. When I is 3, we end up with the third one. And when I is 4, we end up with the last one. And then now we just need to print, and we're summing what? Sum of numbers. Should be numbers, not number. We have several numbers here. So that should give us our output. So this is a very simpler process, but it can get very tedious, because if the list grows or becomes maybe into thousands, then it will not be easy for you to encode all of the numbers in your list. So be aware, this is not a good practice. It might seem easier and very good for you at the beginning, but then when you're given a list with a lot of numbers, it can become a problem. Unless you have the list of these numbers already generated, maybe by the internet, maybe you are tapping into some software that generates the list automatically, that will be good. Okay, so let's see. We should get the same result. Perfect. You can see. So the last method, which is method number 4, will require us to use the summation formula. So here I'm going to define a function called sigma, which gets as its input n. And remember, in the summation formulas, we had a formula for summing of I, and there was a formula for summing a constant. So if you go back to the previous video, you should be able to see that, right? So what do we need to return? This function should return n times the n plus the sum of n and 1 divided by 2, right? And then it should also include So that is for the I. It should also include 10, which is the constant, times n. So that is what the function should output, should return. So notice that this is the function for the summation of I, and this is not the function, but the result for the summation of I, and 10 times n is sort of the constant times n. So refer to the previous video if you don't remember the sums of I and the sums of 10 functions. Once we finish that, let's see if we can output. Should be sigma of our n is 4. So remember, I goes from lower index to the upper index, and the upper index is n. And we should expect our result to be 50. Perfect, you can see. So you have seen the different methods in which you can be able to apply within Python to be able to find a sum of numbers or a list of numbers using the Python programming language. And you have seen the connection to mathematics. So this is a very easy way and very nice way to learn mathematics while you learn how to program. I hope you liked this video. If you did, like our channel, subscribe, comment. In our next video, we will be able to maybe discuss some applications of Sigma notation. Thank you.